Yes, class. Am I audible to all of you? Sidra, Yahya, Harsha, Mariam, Rishita.
Yes, ma'am.
Yes, ma'am.
So just for the month of Ramzan, we have to start the class 10 minutes late. All right, because here the timings are 6:30 exactly when the class starts. All right, so that's why. Let us see what all things we had seen in the last class. I hope you all have revised it. So electric charge only. This was the topic that we had completed, electric charge. This only we did. So what was electric charge? Electric charge is the basic intrinsic property of matter that gives rise to various other phenomena. And SI unit is Coulomb. Two types of charges existed, positive and negative. And this is the minimum amount of charge that is held by a single electron or a single proton. All right. That is 1.6 into 10 to the power minus 9. This is held by a single electron or proton. Then we see it's the transfer of electrons that make the conduction or the charging possible. Protons do not move because of the strong nuclear forces and weaker electrostatic forces. This we had seen. And amongst the charging, that is the transfer of electrons, we had seen one method that was charging by friction. In this, I had told you, see, both the bodies will be rubbing against each other. When two bodies will be rubbing against each other, heat energy will be produced, and that will allow the transfer of electrons to occur, right? Now, in this, you have to remember the statement which I told you, that in which the bonding is strong. So if in B, electrons were strongly bonded in this particular example, then we had seen removal of electron was easier in A. So A became positively charged, B became negatively charged, right? And these two by sign convention, glass, rod, silk, wool, and plastic, woolen cloths and plastic, this you have to remember because this is given. It can be asked to you. Now coming to this question, first write it down. I'll discuss it's based upon the charging by friction only. So it depends upon which bonding is stronger. All right. If one is becoming positively charged, other is becoming negatively charged, then how will the conduction will occur? Transfer of electrons. Write it, then I'll discuss it. See, let's discuss it now. This says that if an object made of substance A is rubbed with an object made of substance B, then A becomes positively charged. So A is positively charged and B becomes negatively charged. Now, on the basis of the concept which we had seen in the last class amongst charging by friction, you tell me which has a stronger bond, B or A?
B.
Yes, B. Because A is allowing electrons to move out. That's why it's becoming positive. And B is just gaining up electrons. That's why it's becoming negative. So this shows that one thing, that A is less or B is stronger than A, right? Then it's, and reason behind this is that How do we conclude this fact? This is through the concept of charging by friction. This is only one line where your charging by friction concept is involved. So electrons are weakly bonded in A than B. In A than B, this is the reason. Then it says C was also introduced. If, however, an object made of substance C, then A becomes negatively charged. That means C automatically becomes positively charged here. This is saying A is negatively charged and C is positively charged. Now, what can you say about this? Which has the stronger bond, A or C? Yes, class, A or C?
A.
A.
A has a strong bond,
Yeah.
right? Because A is negatively charged now. Amongst A and C, we can conclude the fact that A and C both are present, right? Now, if C has a weaker bond, then only electrons will move from C to A. So you can say now A is stronger than C. Now, what do we have to find out in this question? What will happen if an object made of B and C are rubbed against each other? Now you know the order. If B is stronger than A and A is stronger than C, so amongst B and C, you tell me which one is stronger?
B, ma'am.
A.
A. Just write in the chat column, all of you. A or amongst B and C, I'm asking Rishta. See, three are present. B, A, C. According to you, what will be their order now? You know B is stronger than A and A is stronger than C. So amongst B and C, we have to find out because now B and C are being made to rub against each other. B. Good. Harsha, yeah, good. See, B is the strongest. It's stronger than A. A is further stronger than C. So B is definitely has the strongest bond. So order will be B has the greatest. Then followed by A, at the last followed by C. But right now we are concerned with C and B. So now you can see if C has the weakest, then it will allow electrons to move. So now can you predict what should be the sign of B and C? Okay, just tell me for C.
Positive.
Write in the chat column, all those voices are not coming. If I'm not able to respond, I think Yaya has also unmuted himself. Yes, Harsha, correct. Sidra, good. Yes, Yaya, correct. Positive. Because C has the weakest. So electrons will easily escape from C. So this will be positive. And since B, this has the strongest, this will become negatively charged. So prediction of sign can come. Quickly write it down. Those who were saying they haven't written the question, write down the question. And then we'll come to the second, charging by conduction. Again, I am repeating all of you. We are going slowly initially. Do not worry about the syllabus. Initially, for the first 4 lessons, since they are very important, we'll be taking time. If in your school exam, you have your school exam, unit exam, just let me know in the WhatsApp. I'll share my number also with you. Few students already have, some must not be having. I'll share my number. Just let me know whichever portion is coming. I'll prepare you separately. But let the class going at its own pace. Write it, then we'll start with charging by conduction. Just text done in the chat column. Now, see in charging by conduction, what happens? In charging by conduction, same thing occurs as that of friction. Just the difference is that both the bodies are placed in contact with each other. And they are not rubbed. In friction, contact was made there also, but both the bodies were rubbed. That's why heat was produced and transfer of charges occurred. It's just that here both the bodies are placed in contact with each other. And due to the surface contact, the electrons move. So that is charging by conduction, which is also one of the common methods of charging. So here, you have to understand one thing. If both the bodies are identical, suppose I say this is present, this is A, and this is body B. Now charge on this is 4E, charge on this is 0. Now, once they are made in contact with each other and just kept like this, this is A, this is B. Now what happens? The total charge gets distributed equally. What is the total charge right now? Total charge is 4E plus 0. And this gets divided equally. That is 4E gets divided between 2. So divided by 2 will give 2E. That means this will receive 2E after conduction. This will receive 2E after conduction. But what is the condition? Only one condition is present in your syllabus. That is if both the bodies are identical. This I think I have written also, yes. If both the bodies are identical, then charge gets divided equal. Let me give you one more example, then one proper question we'll see. Suppose this is one body A. This is one body B. Let's say in the body A, the charge is 4E. Here in the body B, charge is minus 80 because you can get negative charges also. Now what we'll do? What is the total charge? 4E plus minus 80. That becomes minus 80 only. And how many bodies are there? 2 bodies are there. So divided by 2. So this becomes minus 4E divided by 2. That becomes minus 2E. So it means this will be receiving minus 2E. This will be receiving minus 2E. Use proper signs wherever needed. One question, let us see also. This is a question from your NCRT. Write it down first, then we'll see this question. But just remember one thing. If they are not identical, this formula will not be used. Then that is calculated experimentally. And that's why we do not study this. We just study if the bodies are identical. And in the questions also in the exam, it will be mentioned to you that both the bodies are identical. Okay, in this question, all of you tell me in the chat column what will be the charge on A, B, and C.
Yes, A and B have charges for and a third identical uncharged sphere is first placed in contact with A, then
Yes. First, B is made in contact. See, two identical spheres are present. They have these charges. A and B, both of these have these charges. Third, identical uncharged. Identical uncharged means it has no charge. First, it is made in contact with A. Now, charge distribution will occur. Then whatever is remained in B, whatever is remained in C, now that is made in contact with B. Means C is first made in contact with A, charge distribution occurred, then C is made in contact with B and final charge distribution occurred. So you have to tell that final charge distribution on each. Try, I'll be discussing it, but at least try it once. The concept and the formula, everything that we'll be using will be this only, which we have studied. Yes, class, answers.
say the answer, or should I have to type it?
Yes, Harsha. Correct answer. Very good. See, all of you. Two identical spheres A and B have charges plus 4e and minus 2e. Right? This is given. It means if I'm talking about two spheres, this is one sphere. This is another sphere, right? This is A, this is B. So they have charges here. This has plus 4e, this has minus 2e. This is what is meant by the first line. Now see, two identical spheres have these charges. First line done. Now, if these charges are present, then it says a third identical but uncharged. It's identical, so we can use the same concept of charging by conduction. It's uncharged means the charge that it is containing is zero. It's simply zero, the charge that it is holding. Let me make this as C only. So first C is present, this is C. First, C is placed in contact with A, means with this zero charge, A and C are made in contact. So if they are made in contact and both of them are identical, so charging by conduction will occur and the charges will be distributed equally. So this example also we had seen. This will be plus 4E plus 0 divided by 2. That is, this will be having plus 2E. Here also 4E plus 0 divided by 2. That is, this will be receiving plus 2E. Now the charge of A that was plus 4E now became plus 2E. And the charge of C that was 0. Now it is from 0 to plus 2E. Because of charging by conduction, they were placed in contact with each other. The bodies are just made in contact with each other in conduction. They are not rubbed against each other. All right. Now, come to the second part. Then it is made in contact with B. That is C. These are both the bodies. This is B. Look. This is body C. This is body B. What was the charge on body B? Minus 2E. This was given in the question that the charge on body B is minus 2E. So look, charge on body B, this will be minus 2E. And C was initially uncharged, but is it directly coming in contact with B? No. First, C is made in contact with A, where the charge distribution occurred. So now C, instead of having zero charge, this is having plus 2E. Right? Because this is the present charge. Now, this is also not the final charge because B and C are also made in contact with each other. If they are made in contact with each other, then again charge distribution will occur. Charging by conduction will occur. Reason is that both of them are identical. So see, plus 2E minus 2E divided by 2. They cancel each other. This is 0. This also plus 2E minus 2E divided by 2. 2E minus 2E will be 0. So, as a conclusion, finally, what are the now final charges? On A has starting, it had 4E initially. Now it has plus 2E. B had minus 2E. Now it became 0. C was initially uncharged, then got 2E charged, then again finally has C. So this is how you have to write all your answers in charging by conduction. Write it down. Then we'll see charging by induction. That is the last method of charging. Fine. Write it. Any doubts in this? Let me know. If you're not audible, just type it in the chat column. All right. I'll respond. Others also, just write done once completed. Okay, let's start with charging by induction now. Now, see, charging by induction is different from charging both of the other charging, as in this, no contact is made. In friction also, there was a minimum amount of contact that was, a maximum amount of contact was made in friction. Both the bodies were rubbed. In conduction, they were also made in contact with each other, though rubbing was not occurring. In charging by induction, induction means only without contact, charges are moved. So concept of induction will be used in your capacitors also. We'll be seeing the capacitances, capacitor plates. There also the same concept applies. Now see how do we first just understand through this example. See, this is what an object that I have taken or a conductor I have taken. Here, amount of positive charges and amount of negative charges both are equal, right? So I told you a term. What do we call such objects?
Neutral.
Neutral. Positive and negative charges are equal. We say it is neutral. So what have we studied about the positive and negative charges? Here, the negative charges, they are mobile. That means they have the tendency to move. And the whole concept, how this occurred, nuclear force, that we have already studied. We're not go into that. And what about the positive charges?
They do not move.
They are always at rest. They do not move. So again, we have to keep in mind that negative charges will only be moving. So this is a conductor that I have taken. Now, I have taken a glass rod. And this glass rod, I have made it, let's say, positively charged. At least this concept you all know, that unlike charges like positive and negative will be attracted, and like charges will be repelled. That is positive will be repelled, and negative will be repelled. I hope this you all know. Now see, if I bring this glass rod and I keep it like this, ultimately what will happen? Negative charges or positive charges, both are present. This is the glass rod. And I have made it positively charged. All right, all the negative electrons I have transferred it to. Now tell me one thing. At this end, which charges will be accumulated over a period of time?
Negative.
Negative.
Negative, correct. Because positive charges from the rod, suppose this is the rod and this is the glass rod. It is just kept at a distance, but because of the electrostatic forces of attraction, it will bring all the negative charge towards itself. Right? Like this, all the negative charges will be coming, and slowly over time, what will occur? The positive charges will be there at one place. So all the negative charges, suppose these are present at one end, and the other end, all the positive charges will be accumulated. Till the time, there is a specific condition for this, that till the time this rod is containing positive charges and is kept, As soon as the rod will be removed, again the one positive, one negative, one positive, one negative, they will combine, they will neutralize each other, and again the body will become back to zero. All right. Right now, what has happened? Because of induction, that is the attraction of the charges without the contact, all the negative charges were attracted by the glass rod, and all the charges came at a corner where the glass rod was present. As soon as the glass rod will be removed, so we have successfully separated the positive and negative charges. So this process of separating the positive and negative charges without actually placing them in contact with each other is known as induction, like glass rod helped us. So induction is this process. This you will be using in capacitor also. The capacitor plates are present like this. They do not touch each other. They are present like this. But still the transfer of charges are. How? Because of induction. If one becomes positive, other gains negative, then other becomes positive, like this, charges move. So these charges, like the charges present on the glass rod, these charges, these are known as the inducing charges. Because of these, the other charges have been separated. So this is known as these charges are known as the inducing charges. All right. Because of these, the process of induction could come. All right. And what about these charges that were induced? So we say them as induced charges. These are what? These are induced charges. These are induced charges. All right. So you have inducing charges that separate the positive and negative charge. Then you have induced charges which are being separated because of the inducing charges. And this entire process of separation is known as induction. Now, one thing, if I remove this, suppose this is not present, if I remove the glass rod, immediately positive, negative, positive, negative, positive, negative will make their pair, they will combine, and finally neutralization will occur and the body will become back to its initial state with which we have started. So is it temporary? Right? This is temporary because till the time the effect of glass rod was present, or till the time the effect of inducing charges were present, we could see. So induction, whenever we say charging by induction, you have one more term in your books. That is, this is known as temporary electrification. This is known as temporary electrification because temporarily we have separated the charges. Now, one more term you have, but that we'll be studying in detail in chapter 2. When a charged body is placed in near a neutral conductor, it induces charges due to redistribution of electrons. This is the definition of charging by induction. In non-conducting materials, dielectric induced charges. See, non-conducting material, it's better if you use the term insulator right now. Insulator, you all must be familiar with the term insulator. It's better to use the term insulator right now. Though the term dielectric, and this we'll be studying in charging by potential, electric potential. So some terms like insulators, which do not allow conduction to occur, they are known as non-conducting material. And there is one specific type of these which is known as dielectrics. You have a full concept of dielectrics. That time induced charge is not equal to inducing charge. Otherwise, both of them are usually same. Why? Because one positive will be attracting one negative, then one positive will be attracting one negative. Likewise, they are always equal. But in dielectric, they do not become equal because the conduction is not only possible there, right? If conduction is not only possible, then how the induction process will occur? So this is that. Yes, I was talking about the term earthing. Earthing means whenever a body, why do we need this? We need this because, see, if I have separated the charges, positive I have separated, negative I have separated, but if I want the body just to have the negative charge, then what? Or if I want the body to just have the positive charge, then what? We have to remove one charge completely from the body. We have separated it using induction. Until the time the glass rod is kept, we'll be able to separate it only. But what if we want one charge only to be placed in the material? Right? So there has to be a mechanism by which charges move. That process is known as earthing, where the charge moves to the earth, directly to the earth. That's what we call as earthing. So you have a full detail about earthing in your electric potential, because in case of earthing, your potential becomes zero. Now see, whenever a body is connected to earth, its potential becomes zero. So it means if this is the body, earthing has this symbol like this. This means you have connected the body through a wire into the ground. This means that actually doesn't occur. Even if we touch something, we are able to feel the electric shock, right? Why? Because human body is a conductor. So charges pass through us, and through us they go into the earth. So that is what is meant by this symbol. That is earth and the body, they have been connected. All right. In this case, just remember term potential is zero. Just keep in mind, just write it down in your notebooks. When you will be studying electric potential, that time you will be able to relate it. And this is the symbol for earthing. Now, in earthing, what happens? If the body is negatively charged body, if the body is negatively charged bodies, electrons flow from the body to the earth. Means all the electrons will move from the body bound back to the earth. So all the electrons will be removed from the body. So negatively charged body, electrons move from body to earth. And if the body is positively charged body, electrons move from earth to the body. This is just a small rule which you should remember. Otherwise, you should just remember that if you have earthed it, the charges will move. All right, just remember this for now. We'll see a question also. So what is earthing? In earthing, you make the potential zero, so charge is zero. So one of the charges moved. And what was charging by induction? Temporary electrification. Is this clear till here to all of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Rishita, Harsha, clear?
Yes, ma'am.
Yes, ma'am.
All right. Write down then charging by induction till earthing. Then we'll see a question that will at least complete the charging methods of charging portion. All the electrons move till the time you have connected it. So if you have connected it for a long time, Harsha, then all the electrons will move. But if you have connected it for a short time only, so some electrons might remain in the body. But it's
Okay.
not specific for any excess electron, because electrons have the same property, whether it's excess or if they are deficit, right? So all the electrons will move.
Okay.
See, this says that make this isolated sphere as positively charged sphere. So this sphere is present. Now we have to make this only positively charged, right? So see, this is the sphere which is given on an insulating stand. Why? So that the charges do not move. So we'll bring a glass rod, but since we have to make it positively charged, let's bring up the negative glass rod. Let's say this is negatively charged. So what will happen? Positive charges will be accumulated at this end. Negative charges will be accumulated at this end. Now, keeping the rod at this position, if I perform earthing here, glass rod has to be there, because as soon as the glass rod will be removed, the body will become back to the neutral. So this is positive here, and all the negative charges are moving, either coming from the body, moving, they are making it neutralized, right? So no charge is left here. That is, Q will here will become 0 because the potential is also 0. Potential means steady. Now I will remove the earthed portion. Glass rod is still here, negatively charged. So all the positive charges are present here, and this side has no charge. That is, this is neutral. All right. Now, finally, if I now remove the glass rod also, what will happen? The charges will redistribute, but there are no negative charges to make it back to neutral. So what will happen? I'll just have the positively charged sphere. So this question is there in your in-text NCERT also. So this is an important question. Like this only you have to make the diagram and write it. So this is what? This is positively charged, identical, isolated sphere. All right. This is how you had to follow the steps. Now charging is over. Quickly, let us discuss the properties of the electric charge, so that at least electric charge will also be towards an end. Write it down. And just text me done also once you have completed a topic. So I'll also have an idea who all are writing, who all have not written. Now let's start with the properties of charges. Yeah. So see, first three properties are very easy and you do not have questions also from these. If properties of charges come to write, just in short, write all of these. One fourth point, we'll discuss it in detail. Additive nature of charges. We have already discussed that charges are what? They are scalar quantities. If they are scalar quantities, you can directly algebraically add it. Suppose there is a body present. It has +2 coulomb, it has -1 coulomb, +3 coulomb, -2 coulomb, all these mixture of charges are present. So if I want to find out what is the net charge, I'll just add it because they are scalar quantities. So you can add all the charges that are present. So this will be +2 coulomb, +3 coulomb, -2 coulomb, -1 coulomb. So +2 -2, this will become 2 coulomb, right? So the net charge will be simply +2 coulomb. So net charge on the body is whenever you are calculating, whenever you have to find out the net charge. This will be simply algebraic sum. Algebraic sum of all the individual charges present. All right, you'll just add it. Come to the second, that is conservative nature of charge, conservation of charges. Then second is conservation of charges. All right. When we're talking about the conservation of charges, charges can neither be created nor they can be destroyed. It means we have already studied that it's the transfer of charges that occurs, right? So if a body is negatively charged, it's not because some additional negative charges are being built up there, or if a body is positively charged, it's not that some additional positive charges are coming into the body, right? So transfer of charges occur means from one body to another, the charges simply move. So if one has positive charge, it means charges are moving from positive to negative. Invariance of charge is also very easy. Invariance of charge means that charges do not depend upon the speed. That is, if I say if there is a body, this has a velocity. Let's say this has a velocity of 5 meter per second, and the charge this body A is holding is +4 microcoulomb. Fine. Now slowly the speed of this body increased. This A speed increased, and from VA 5 meter per second, the speed increased to, let's say, 10 meter per second. This became 10 meter per second. So if the speed is doubling, the charge shouldn't be now 8 microcoulomb. No, charge will be still +4 microcoulomb. We just know the fact that transfer of charges will occur, then only the charge distribution will occur. Otherwise, the charges do not depend upon the speed. Now, the last portion, that is very important, quantization of charge. Let's discuss this also. This is the most important property. Why? Because separate questions are also present in your exam on the quantization of charges. You have separate questions, numericals are there from this portion, in text question also, and your back exercises also. So what is meant by quantization of charges? See, one electron is holding how much charge? 1.6 into 10 to the power -19 coulomb. This I have told you that you all have to remember, because this will be used everywhere, not only in this lesson, in the upcoming lessons also. So amount of charge that a single electron is holding, this is 1.6 into 10 to the power -19, right? If I say 2 electrons, then according to you, what should be the amount of charge? One is holding this, so 2. Yes, Rishita?
2 point. It'll be a 3.2 Into 10 raised to
3.2,
minus
right?
19.
That is 2 times this, correct. If 1 is holding this amount, so 2 will hold 2 into 1.6 into 10 to the power minus 19. That is rightly answered by Rishita. That is 3.2 into 10 to the power minus 19 coulomb, correct. If I say 3 electrons, this will become 4.8 now. Why? Because 3 into 1.6 into 10 to the power minus 19. So this becomes 4.8 into 10 to the power minus 19 coulomb. Similarly, if I put 4 charges, that will become 6.4, right? Like this, all the charges will increase. So can you see one pattern? Can you see one pattern? One electron was there, so 1.6 into 10 to the power minus 19. 2 electrons, so 2 times this. 3 electrons, 3 times this. 4 electrons, 4 times this. Means n number of electrons will be how much? Number of electrons, if it is n, what will be the total charge? Total charge will be that n amount multiplied to this E. That is electronic charge. I have already told you. This is known as electronic charge. E is the electronic charge, that is the charge held by a single proton or neutron, proton or electron, which is 1.6 into 10 to the power minus 19, which is represented through this symbol E. So what is the formula? Q is equal to NE. This is the formula that you have to remember. Means 1 times this, 2 times this, 3 times this, that is, it's an integral multiple. Remember, charges are always integral multiple of E. This quantization of charge means what? Charges are integral multiple of E. And what is E? That is, E is the electronic charge, that is 1.6 into 10 to the power minus 19 coulomb. What is meant by integral multiple? When I use the term, what is meant by integral multiple? See, integral multiple means there are only 2 possibilities. If one electron has 1.6 into 10 to the power minus 19 coulomb, 2 electrons will have 3.2 into 10 to the power minus 19 coulombs. In between, nothing is possible because either electron can be 1, next it can be 2, then it can be 3, then it can be 4, like this. One electron, if it is having this value, another electron, this is having this value. Electrons, whatever value they are holding, whatever values they are having, it will be integral multiple of this number. It will be multiple of this number. Multiple is fine. Why? Integral means complete. 1, then 2. You don't have 1.5 electron present. So it means after this, this. After this, this only. Nothing in between is possible. After this, 6.4 into 10 to the power minus 19. Like this. All the 4 properties are clear to all of you? Any doubts in any of the properties? Yes, no, clear or not?
Clear, ma'am.
Clear, ma'am.
Sidra,
ma'am.
clear?
Yes, ma'am.
All right. Write it down. Anything you want to ask, you can note it. And numericals come from quantization of charge. That formula Q is equal to NE, that is important. That's the first formula from your lesson. You didn't have any formula till now. That's the first formula. And the numericals will commence from there only. Also, just let me know once you have completed, so that you can then appear for your after class assessment. You have your after class assessment now. That is, you have to log into your Learnivio portals account, log into your account, and there from there you have to appear for the class after class assessment. There the questions, 5 questions will be there, and you have to attempt all of these where one advanced level will occur. Like the first question will be very easy. Question fifth will be the toughest one, and the syllabus is the topic that we have completed. That's it. So just appear so that I'll also have an idea. Those marks will not be added anywhere. You'll be having your separate exams that will be going on, regular class tests. This is just so that at least you will also have an idea what all you have understood, and that will also give me an idea what you all have understood. All right, so just all those who have completed, appear for after class assessments. You can leave the meeting, but there you'll be having the after class assessment going on. The maximum time is half an hour, but that depends on how much you have completed. If you can complete it in 10 minutes, that's also fine. Many students are able to complete it in within 10 minutes also. So we'll be meeting on Monday now, again 10 minutes after the class timing. That is after the Maghrib Azan that occurs over here. So that is 6:40 around. We'll have the class on Monday. And I'll just discuss 1 or 2 questions from this quantization of charge. And I'll be starting straight away with electric field now. Coulomb's law now. All right. So we'll be starting with Coulomb's law. That is similar to your gravitational law, universal gravitational law by Newton. So just revise that and come. That will help here. All right, class. Thank you so much. Anything you want to ask, you can stay. Otherwise, thank you so much. We'll meet in the next class.
Thank you.
Thank you, ma'am.
Thank you, ma'am. Bye, ma'am.
Ma'am, I won't be able to do the class assessment test.
Yes, yeah, you're asking something?
Yes, I won't be able to do the class assessment test because I have yet to log in the Learnivio. I tried logging in yesterday, but it didn't help. So I'll
It's
try
not
to.
opening when you are logging it.
Yes, ma'am. The message
Okay, I'll just tell the team once this thing. All right, you can contact them also. I'll let them know also if you're not able to log in it.
Okay.
Yeah.
Thank you.
Okay.